We can compare two cases. In the first case, two blocks or two bodies of masses m1 and m2 are connected to the two ends of a string, and that string passes over a frictionless pulley. These are the two blocks or two bodies. These are the two blocks or two bodies of masses m1 and m2. m1 and m2 are the masses of the two blocks, and here m1 is greater than m2. Weight of the heavier block, that is m1g, acts downwards. m1g is the weight of the heavier block which acts downwards, and tension acting in the string is T. Tension acting in the string is T. T is the tension acting in the string which acts vertically upwards. And the heavier block will be moving downwards with an acceleration A. And the weight of the lighter block or lighter body, that is m2g, acts vertically downwards. Similarly, same tension T will be acting upwards towards the pulley, and the lighter block will be moving upwards with the same acceleration A. In that case, common acceleration of the two bodies is given by A equal m1 minus m2 divided by m1 plus m2 into g. A equal m1 minus m2 divided by m1 plus m2 into g. That is the common acceleration of the two bodies in the first case. Common acceleration of the two bodies in the first case. In the second case, the heavier block of mass m1 is removed. Heavier block of mass m1 is removed, and the lighter block of mass m2 is suspended by a string, and that string is passing over the same pulley, and the other end of the same string is pulled downwards by applying a force F equal m1g. The other end or open end of the string is being pulled by applying a force F equal m1g. For the first case, there are two bodies, and for the second case only one body of mass m2 is suspended and other end of the string is pulled by applying a force F. In this case, in the second case, the lighter body is moving upwards with the acceleration A, and the other end of the string is pulled downwards with a force F equal m1g. In that case, the lighter block or the body of mass m2 will be moving upwards with the acceleration A. Considering the upward motion of the mass m2, the upward motion of the body of mass m2, we get m2 dot A, mass into acceleration is the net force acting on the mass m2, is equal to T minus m2g. For the body of mass m2 is moving upwards with an acceleration A. Net force acting on m2 is m2a, which will be equal to T minus m2g. Net force acting upwards is T minus m2g, which is equal to m2a, which is equal to m2 dot A. m2 dot A is equal to T minus m2g, which is the net force acting on the body of mass m2 upwards. Therefore, T is equal to m2g plus m2a. T is equal to m2g plus m2a, which is equation 1. And this is the tension acting in the string. This is the tension acting in the string to which a body of mass m2 is attached, and the other end of the string is pulled downwards. Again, if we consider the open end at which a force F is acted, in that case, tension T is the tension acting at that end, and the force which is applied to pull the string is F equal to m1g. Therefore, T is equal F or T is equal m1g, which is equation 2. T is equal to m1g, which is equation 2, and T is equal to m2g plus m2a, which was equation 1. Both are the tension acting in the string. Both are the tension acting in the string. Comparing equation 1 and 2. Comparing equation 1 and 2. Comparing equations 1 and 2, we get m2g plus m2a is equal to m1g. m2g plus m2a is equal m1g. Or comma m2a equal m1g minus m2g. Therefore, a equal m1 minus m2 divided by m2 bracket closed into g. A equal m1 minus m2 divided by m2 into g. That is the acceleration of the body of mass m2 in upward direction. And in the first case, or in the left hand side, the common acceleration a is equal to m1 minus m2 divided by m1 plus m2 into g. And on the right hand side, the common acceleration of the block of mass m2 is what you know, m1 minus m2 divided by m2 into g. For the left hand side, the common acceleration a is for the left hand side, in which two blocks are suspended by using a string and string passing over a pulley. In that case, common acceleration a equal m1 minus m2 divided by m1 plus m2 into g. On the left hand side, only one body is suspended and other end of the string is pulled. Common acceleration a will be m1 minus m2 divided by m2g divided by m2 into g. That is the expression of acceleration. In this case, on the left hand side, the other end of the string is pulled by applying a force F equal m1g. So in the denominator, on the right hand side, m1 is equal to 0.